Hello, Leon. It's your Zayde, Mason. I am here today to read you the ABCs of engineering. Now, this is a long book, actually, so we're going to do this in parts, and this will be part one. I don't know how many parts there will be, so we'll figure it out, but ABCs of engineering. Ooh, look, amplifiers and batteries and Carnot engines. Ooh, this will be fun. So, A is for amplifier. See, this is a representation of an amplifier, and you have a little bit of a signal and you have a bigger signal. So an amplifier makes a signal bigger, okay? And an amplifier has an input and an output, and the input is a signal, which is usually electrical. It doesn't have to be electrical. It can be optical. It can be acoustic even, believe it or not. And there are things called passive amplifiers and there are active amplifiers. And in this case, we're going to treat this as an active amplifier, something that is being powered that takes a smaller signal and makes it into a bigger signal, okay? So what the whole purpose of an amplifier is it takes a signal and it makes it bigger, but what it's trying to do is it's trying to keep all the background sounds behind it, or background signals that exist, because they're signals coming from all around us. Whether they're sounds, you can hear sounds all the time, or you can see light all the time, or we're being bombarded by all kinds of radio frequencies all the time. And the best kinds of amplifiers are going to take the signal, and only the signal you care about, and make it bigger and louder or stronger. Okay, so A is for amplifier. All right, let's get to batteries. Ooh, batteries. You're going to learn about batteries because lots of things you use have batteries, like cars and toys and flashlights and all kinds of other things. Okay, so B is for battery. A battery gives power to electrical circuits. It's a way to store power. We keep power stored in different ways through different materials. In this case, this battery is round because this is mostly what you're going to see, except for car batteries, maybe, on occasion. Batteries store energy when not in use. That's the purpose. When they are connected to a closed circuit, so that the circuit allows the electricity to flow from one side of a battery, the positive end, to the negative side of the battery. And we've talked about positive and negative charges. When they're connected, they force electric charges to move with current, and we've talked about that. Not all batteries look the same. There's all kinds of batteries. There's button batteries and big square heavy car batteries and regular flashlight type AA, AAA, single A, B, C batteries. And there's 9 volts, which are kind of like a little rectangle. But they all do the same thing. They all move charge from the positive end to the negative end. And that's the way that the battery works. It stores, usually it's sandwiched between different layers of materials. Some are insulators and some are conductors. And they store the energy in between the insulative materials. And when you connect one insulator type to another, or one conductive piece of material that has electrons on it to another, the electrons flow from the higher potential to the lower potential. So that B is for battery. Ooh, C is for Carnot engine. All right, well, you're going to have heard about engines. So engines are a model of an ideal, well, this is a model of an ideal heat engine, but an engine, heat engines use temperature differences to work by moving energy from hot to cold. Okay, so like a refrigerator would move from hot to cold. The problem with engines in real life is that they waste a lot of energy to do their job. So your car, if you're going to move it from one place to another, has an engine, and that engine burns fuel and mixes it with oxygen, and it drives a drive shaft which pushes the tires and makes the car go. Well, the problem is it also creates a lot of heat, and it's not very efficient. There are different kinds of cars. There's cars that have gasoline for fuel or diesel for fuel. Some use hydrogen for fuel, very rarely. And more we're using batteries like we talked about. So there's a lot of cars that are electric cars that run on batteries. And sometimes the whole car itself is a battery. The less that you require to use fuel itself and just store energy, the more efficient it is. And a 100% purely efficient engine is called a Carnot engine, in which case it produces no extra heat to do its job. So that is a Carnot engine. All right. D is for dielectric. Okay, so dielectric is a material that can be polarized, and you see it's got little charges on there, pluses and minuses, and there's an external electric field that even shows that. Well, all material is made of charged particles, right? So even you and I are made of charged particles, and the book that I'm holding is made of charged particles, and even the phone that I'm using to record this is made of charged particles. But dielectrics are special because the charges in them can be lined up in an electric field. And in this case, the green dielectric, this is a dielectric for our purposes, has all the charges lined up because there's an electric field in the direction of the arrow. So this is called a dielectric, and it's used all over the place in our modern electronics. Okay, we're going to stop. I think we're going to stop now, and I'll come back to E next. This is A through D. So we've talked about amplifiers and batteries and Carnot engines and dielectrics. And next time I do a recording, it's going to be starting with E. And what is E? E is for electricity, which we've already talked about, but we will get into it more with this page, but that will be next time. I love you very much, Leon. This is your Zayde Mason checking out, and I will see you next time with more of this book.